So while I'm letting the rest of the crew in, I'm just going to play a little bit of this dissection before we get into our own.
We are going to remove the whole central nervous system from its attachments. We are now cutting the lateral spinal nerves. And now we're lifting the cerebellum and cerebrum together. And now we're going to the other end, removing the distal extremity of the spinal cord. This whole central nervous system is also called neuraxis or cerebrospinal axis. The neuraxis includes two parts: the brain, which in Latin is called the encephalon. The second part is the spinal cord, or medulla spinalis. Now the encephalon itself has three parts: the cerebrum, or the cerebral hemispheres, the cerebellum, and the brainstem. We are now going to describe some basic brain parts using some Latin words that may seem difficult. These names came from the primary brain vesicles formed in the embryo in the first 5 weeks of pregnancy. The cerebrum, in Latin prosencephalon, is itself divided into the telencephalon, the major mass of the cortex, and the diencephalon, which includes all the parts you can see on the screen. We will go over these parts in more detail later on. The brainstem, or truncus cerebri, is subdivided into three parts. The midbrain is on top or superior, the pons in the middle, and the medulla oblongata is on the bottom or inferior, just before the spinal cord proper starts.
That just gives you a little idea of what the brain actually looks like in the human being. What did you guys think of that? Give me some feedback. You thought it was cool? You thought it was disgusting? You were surprised at what such and such looked like? Give me some feedback. You were surprised at the size or how meaty it might look. When the first time I watched it, I just kept thinking that was in somebody's head. Like that was a living person at one time. And you could see how they took it out of our body and then like what the body looks like. So that's kind of cool. We're going to dissect sheep brains though, not human brains. There is a law against that. When you go to college, maybe you'll dissect my brain because I plan to be a cadaver when I grow up, and I'll still be teaching anatomy even in death. So hopefully you'll be done and out of school by then, and you'll all be doctors and lawyers and all kinds of good things. But we're going to do a brain dissection. Actually, it ends up being quite short. If we were in class, the students are usually pretty disappointed that there's really only like one cut to do. So we have our brains and we cut down the middle, and then we're just looking at the pieces and parts that are on the inside. So that's kind of all there is to the cut itself. So kids are usually a little bit surprised that there isn't more hunting to find the structures. And then I think they're usually surprised at the texture of the brain, and maybe you could kind of get an idea of the texture from that. It's a little bit pliable, and if you stuck your probe into it, you would probably break through the tissue pretty easily. So I think that usually surprises people, the texture itself. So we're going to do a virtual version since we don't have brains to do. You are welcome to come on back next year and do dissections with us. The quiz, you guys wouldn't be an 11:30 crew. I think you'd be 2 o'clock-ish crew. We are supposed to do a labeling quiz today, and I usually like to do the dissection prior to that, and usually, you know, they're on separate days, but we would have plenty of time to come back and take the quiz at the end of our period together. Or because we did divide the test already in half, all you have is the functions piece of the brain. So that's pretty small. That's going to feel more like a quiz. If you'd like, we can, and this is what second hour chose, but you guys don't have to do the same. They chose to just stick the labeling quiz on with their functions quiz next Thursday. So what are your thoughts on that? You want to come back today at 2 and take the quiz, or do you just want to put the two together next Thursday? You can voice it or chat it. So most of us are saying next week. I do have it ready. So like if you really want to take it today, you could come back after your dissection. You can come back into the main room because we're going to do breakouts, and you can get that quiz out of the way if you'd like. Okay. So here's what we have to do. Whoops. I'm going to minimize this for a second. I just want to pull up all of our materials. I see now that I don't have, hang on. I got a lot of things open. Brain labeling, dissection. Here we go. Okay, so in the brain dissection, we'll watch this video. This kind of walks you through what the actual dissection would look like. So we're going to dissect the brain in video. Then you have a worksheet that you will do in a small group. And I'm going to open up the breakout rooms. And if you have that updated version, you can choose who you work with. And then if you don't choose, then I'll just try to remember who you said you like to work with, because I don't have that paper with me. So this is the worksheet you guys will fill out. So somebody in your group either have up the worksheet, or I'm going to show you the virtual lab in a second. Have this out. You put all of your names. You only need to turn in one for the group. I saw some of the groups last hour, they shared the worksheet with the people within the group, and then more people had editing rights. You could do that. That's fine. But let's say Kaylee and Abby are working together, and Abby turns the paper in. Then Kaylee's just going to put Abby's name in the private comment and mark as done. Okay, so then I would look for Kaylee's name to be included on Abby's paper. So only one of you needs to turn it in. The rest of you just say who's in charge of your paper. Okay, so this is the worksheet we're going to fill out, and they got through it really quick. So I realize now I could have been more intensive on that. And then you have this is step by step as you would dissect. This is what the dissection would look like. So you have this link both in the classroom and on the worksheet. So when you first get your brain, it's going to be whole, and it would be in this tough outer dura mater. Remember the 3 meninges? So the dura mater, I told you, was very tough, and you could actually cut it off. So the first thing you would do is look out at the external features. Notice the dura mater is already coming away from the brain, okay? Underneath here, you would see a crisscross. That is the optic chasm. So that allows like your right eye to communicate with your left brain and your left eye to communicate with your right brain. You'd see some other features as we get rid of this dura mater. So here she's cutting the dura mater off. That's the same as you would do in class. The dura mater is quite tough, and so you would use scissors, and you might be surprised at how thick it actually is. So now we can see the optic chasm here that I was telling you about. Up front, you would have the olfactory bulbs. Olfaction has to do with your sense of smell. So these, this would take the sense of smell to your temporal lobe. And then you can see oculomotor nerves means movement of the eye. So you have some different nerves that you would be looking for if we were in person. Here you can see the shininess on top is that pia mater. And I can see the blood vessels, those red things that are kind of brownish and they're stringy. That's pia mater, or I'm sorry, that's the capillaries. If you were in class, you would take tweezers and you would try to separate that pia mater from the brain tissue, and it would not separate. Your cerebellum, you would look at the connection between the cerebellum and the cerebrum. You would cut it in half. You'd be looking at both gray and white matter. So notice you have the gray and white matter in the cerebellum. You have the gray matter on the outside of the cerebrum, white matter on the inside. Notice the big folded U shape. Okay, that's your corpus callosum. Okay. And then you would be looking at your thalamus. Remember I said find your thalamus first and use that as a point of reference. It's kind of circular. Notice these aren't terribly like easy to identify, right? So part of anatomy is knowing where things are in relation to other things. So maybe I don't see an exact circle right here, but I know that I should see a circle right here. And then I kind of visualize that that's what's actually there. So that would be my my thalamus, and then moving forward would be my hypothalamus. And then my brainstem, the first bump, you see your pons, I'm sorry, your midbrain would be above it, your pons, and then the medulla is this second bump here. So you would look through all of these things. You'd look at the spaces. You'd look at the connection of the corpus callosum, how it connects the two hemispheres. This is a nice picture of the thalamus right here. We get excited when you can find a good thalamus. And a pituitary gland dangling down in front. Okay, so that's what you're going to look through in that sense. So that's your virtual dissection that you can use. And then I'm going to play out this video, which is the dissection itself. So you'll see them cutting it. She's going to point out everything on the brain itself.
Okay, so we are going to label the sheep brain for AMP1 at the College of Mount St. Vincent for Professor V's class. Here you can see we have the right hemisphere of the sheep brain. In my hand, you can see the spinal cord. I'll use the probe. So on the spinal cord, you can see that dark line. That is the central canal. You can see here that it bumps out a little bit. On that first bump, we would call this part is the medulla oblongata. Now, you either know that because it bumps out, and that's the first bump, or because right above the medulla oblongata, you have this gap right here. This gap is the fourth ventricle. So here you have the cerebellum, and in between the medulla oblongata and the cerebellum is the fourth ventricle. Tracing that up, we have the aqueduct of Sylvius right here. And above the, inferior to or below the aqueduct of Sylvius, we have this second bump, which is the pons. So here we have the spinal cord. First bump is the medulla oblongata. Second bump, we have the pons. Now, over here, you can see the cerebral peduncle. Above or superior to the cerebral peduncle, we have the two colliculi of the corpora quadrigemina. Here we have the inferior colliculi and colliculus and the superior colliculus. If you were to put both halves of the brains together, you would have two superior and two inferior, making it quadrigemina. So moving on, anterior to the corpora quadrigemina, you have the pineal body. So this round part right here. And then next to that, anterior to that, you have the thalamus, or what's sometimes known as the intermediate mass of the thalamus. Below or inferior to the thalamus, you have the hypothalamus. which you can tell is the hypothalamus because it's the tissue that's either below, below to the thalamus, or it's the tissue in between. See this round gland right here, the mammillary gland, or the optic chiasm. So here you have the optic chiasm and the mammillary body, and in between the two is the hypothalamus, inferior to the thalamus. Superior to the thalamus, we have the third ventricle right here where I'm sticking the probe. Then we have the lateral ventricle right here, this space. And then in class, we talked about the lateral ventricle being similar to a room. So the curtain that separates the two rooms or the two ventricles on the right and left hemispheres is called the Septum Pellucidum. We tore that away so that you could see the space in the ventricle inside. Now this part that I'm pulling down on so that you can see the space, this tissue right here is the fornix, or what would be the floor of the room, so floor, fornix. Above this white tissue here, what would be the ceiling of the room that I'm pushing on, that is the corpus callosum, and that would be the ceiling of the room. So C, corpus callosum, C, ceiling. So, oh, and then we have the olfactory bulb underneath the brain, or inferior to. So really fast, one more time, going through, we have the spinal cord with the central canal, medulla, bump 2, the pons, the cerebral peduncle, aqueduct of Sylvius, and the fourth ventricle. Cerebellum, corpora quadrigemina, inferior colliculi, superior colliculi, pineal body, right here, thalamus, hypothalamus, mammillary body, posterior, optic chiasm, anterior. Then we have the third ventricle, fornix, pull that down to see the lateral ventricle, and then above that is the corpus callosum. There should be the septum pellucidum, but we tore it away. And then the olfactory bulb. This entire part, we're not going to label the different sulci of the cerebral hemisphere. This entire thing for our class just needs to, you need to know that's the cerebral hemisphere. And that's the sheep brain. Good luck next week. You guys will do great.
Okay, she even wished you guys good luck next week on your quiz. Okay, so that's what the true dissection looks like. So do you guys have any questions on this?